morning, class. I'm Mr. David Ayoro, a teacher of chemistry. Welcome to our class. Today's lesson is on electrochemistry. Electrochemistry is a very wide area which we want to revisit again. We had discussed it earlier, but we want to revisit it again so that you may understand it properly. So we have got two terminologies there, electro and chemistry. Electro comes from the word electrons. Electrons. So it is based on reactions in which electrons are transferred from one substance to the other, that is redox reactions. You know, RE is for the word reduction, RED, and ox from the word oxidation. So it's a reaction in which electrons are transferred from one substance to the other. Let us see, this is our example. Copper 2 sulfate reacting with iron, giving us iron 2 sulfate plus copper. This is a typical reaction which involves redox. If you write the ionic equation by cancelling the spectator ions, then we will come up with copper 2 ion plus iron, giving us iron 2 ion and copper. In this case, the copper 2 ions will gain 2 electrons from iron, giving us copper metal, and iron is going to be oxidized to iron 2 oxide, to iron 2 ion. So in this case, copper 2 ion is gaining electron, hence it is reduced. That is to say, the gain of electrons is reduction, while iron is losing electron, hence it is oxidized, because the loss of electron is what we call oxidation. So as copper 2 ion is being reduced, iron is being oxidized. This kind of reaction is what we call a redox reaction. That is, the reaction between a metal and a metal ions of another metal involves transfer of electron from more reactive metal to the other ion in the solution. What we are saying is that if you react metal plus metal copper 2 ions, because iron is if you have iron and copper 2 ion, because iron is more reactive than copper, it is going to displace copper from the solution, forming iron 2 ion and copper metal. So this kind of reaction, where we write the ionic equation, is what we call the full cell equation. The full cell equation. That is to say, from the full cell equation, we can get the two half ionic equation. The first one, iron losing electron to form iron 2 ion, then the 2 electrons lost by iron they are gained by copper 2 ion to form copper metal. So this is what we call ionic half equation. Because it's a displacement reaction, heat is released. So the amount of heat evolved in these reactions depends on the position of the metal in the reactivity series relative to the metal ion in the solution. That is to say, more reactive metal, such as potassium, will lose electron more readily, and thus they are stronger reducing agent compared to the less reactive metals such as silver and mercury. What we are saying is that if you react, if it was copper 2 ion reacting with potassium ion, we are going to get potassium ion plus copper. This is also a full cell equation. But because potassium is very high in the reactivity series compared to iron, the kind of displacement which will take place here will be more compared to the kind of displacement which is going to take place between iron and copper. So we find that the heat energy evolved here will be higher compared to the heat energy evolved when this kind of reaction takes place. That's the reason why we're saying that the amount of heat energy evolved in this reaction depends on the position of the metal in the pivot series compared to the metal ion which is in the solution. So we have got oxidation number. What is oxidation number? Oxidation number, also known as oxidation state, is the apparent charge that atoms have in ions or in molecules. This oxidation number we discussed in Form 2, and we say that all group 1 metals will react by losing one electron, like sodium. Sodium reacts by losing one electron, so it has an oxidation number of +1. Group 2, like calcium, reacts by losing 2 electrons, so oxidation number of +2. Group 3, like aluminium, will react by losing 3 electrons, oxidation number of +3. Group 4 can be +4 or -4 because they can react by losing 4 electrons or gaining 4 electrons. Group 5, like nitrogen, reacts by gaining 3 electrons. They react by gaining 3 electrons. Like nitrogen will react by gaining 3 electrons to form nitrogen ion. So you have got oxidation state of -3. That is group 5. Group 6, like oxygen, reacts by gaining 2 electrons. So they have oxidation of -2. Group 7, like chlorine, reacts by gaining 1 electron. Oxidation state of -1. So oxidation is the apparent charge an atoms have in ions or molecules. The concept can also help us in determining whether a substance has been reduced or oxidized. That is to say, an increase in oxidation number is what we call oxidation, and a decrease in oxidation number is what we call reduction. So before we look at the equations involving increase and reduction of oxidation number, let us look at the individual molecules. So examples, number 1, find the oxidation number of the following atoms in bracket, like H2SO4. We want to get the oxidation number of sulfur here. We know that hydrogen is either in group 1 or group 7, but they have got oxidation number of +1. So we have got 2 atoms of hydrogen, and hydrogen has got oxidation number of +1, plus sulfur, which we want to get. Oxygen have got oxidation number of -2 because they have to be gaining 2 electrons, and we have got 4 molecules of them, is equal to the charge. Because this one is not charged, the oxidation number is, the oxidation number is 0 here, so it's equal to 0. So 2, open the bracket, 2 plus sulfur S minus 8 is equal to 0. So if you collect like terms, S will be +6. So this one, sulfur has got oxidation number of +6. That's the reason why we are calling this substance sulfuric 6 acid. If you look at this molecule, we want to get the oxidation number of nitrogen here. Hydrogen has got oxidation number of +1. Nitrogen we don't know. Oxygen is always -2, but we have got 3 more atoms here. And because this one is not charged, the oxidation number in total, if you add all of them, add up to 0. So 1 plus n minus 6 is equal to 0. It means that the oxidation number of nitrogen here will be +5. That's the reason why we are calling this molecule as nitric 5 acid. 5 means the oxidation number of nitrogen. Look at this one, a compound which is charged. We want to get the oxidation number of chromium in this compound. We have got 2 atoms, so we have to get the 1 atom of chromium. So we have got 2 chromium plus 7 atoms of oxygen, but 1 oxidation number of oxygen is -2. So is equal to the charge which it contains. This one contains a charge of negative 2. Negative 2. So 2 chromium minus 14 is equal to negative 2. If you collect like terms, 2 chromium is equal to positive 12. It means that 1 chromium is equal to positive 6. So the oxygen number of chromium here is what we call is positive 6. So number 2, in terms of oxygen number, state with reasons the substance which is reduced and the one which is oxidized in the following equation. Look at this equation. The equation involves iron plus chlorine gas giving us iron 3 chloride. Oxygen number of any compound which is not charged, a molecule which is not, a compound which is not charged has got oxygen number of positive 0. Like this one is now positive 0. Chlorine, because it's not charged, it's a molecule, 0. This one is a compound which has been two atoms combined together. So here, the oxygen number of chlorine is negative 1, because chlorine just by gaining 1 electron. So here, iron has got oxygen number of positive 3, because it's iron 3 chloride, iron positive 3. So because iron, the oxygen number of iron is increasing from 0 to positive 3, it means that iron is oxidized, because the oxygen number increases from 0 to positive 3. It means that this iron, since it's oxidized, is a reducing agent. Chlorine. Chlorine, if you look at chlorine, the oxygen number of chlorine reduces from 0 to negative 1. Because the oxygen number it reduces, chlorine is reduced. Because it is reduced, it's an oxidizing agent. That is to say, in terms of oxygen number, a substance whose oxygen number increases is oxidized, and the one whose oxygen number reduces is reduced. Like chlorine is reduced and iron is oxidized. Look at this assignment. Find the oxygen number of the following atoms in bracket: nitrogen and potassium and this compound. If you look at nitrogen, I want to give the hint. Nitrogen, we don't know its oxygen number. But oxygen, we know oxygen number, which is negative 2. So it will be nitrogen plus 2 atoms of nitrogen, and one oxygen is equal, one of them has an oxygen number of negative 2 is equal to the total charge which this one contains, which is 0. Then you expand this one, becomes 9 minus 4 is equal to 0. So nitrogen is equal to positive 4. So this is what we call nitrogen 4 oxide. Nitrogen 4 oxide. Look at this one. Potassium. Potassium, positive 1. Manganese, we don't know. Plus, oxygen, we have got 4 of them. And the total oxygen number of oxygen, the oxygen number of oxygen atom is negative 2. Is equal to the charge. The charge, because it is not charged, is equal to 0. If you expand this one properly, then you will get the oxygen number of manganese here is equal to positive 7. So this is what we call potassium manganate 7. I want you to try sodium reacting with water, giving us sodium hydroxide plus hydrogen. But I told you earlier that here nitrogen, sodium, because not charged, oxygen number is equal to positive, is equal to 0. Here hydrogen will be positive 1, oxygen here will be negative 2. Oxygen, sodium here, because it's a compound, positive 1, oxygen here, negative 2, hydrogen, positive 1, and hydrogen gas, 0. So you find that sodium, because the oxygen number increases from 0 to positive 1, so here sodium is oxidized, because the oxygen number increases from 0 to positive 1. If you look at here, hydrogen is maintained, but oxygen, if you look at this one, hydrogen here, hydrogen, the oxygen number decreases from positive 1 to 0. Hydrogen, positive 1 to 0, then the whole of this water is reduced. It is reduced because the oxygen number of hydrogen decreases from positive 1 to 0. So that's how you look at the oxygen number in terms of reduction, in terms of oxidation and reduction. Thank you. We are going to continue in our next lesson with the other elements of electrochemistry. Thank you.